Hi, my name's Hannah. I'm going to take you through a quick demonstration of eukaryotic gene mapping. Um, so we're given a raw set of data and it's totally jumbled up. We've got to reorganize it. And to do that, we go through and we look for numbers that are similar to each other, like 1010 and 970. Given that these individuals occur pretty much as frequently as the other, we can assume that these must result from the same crossover. Same thing with these guys, 420, 400, super close together. Um, they must go together. And then these guys are kind of special because you see 140 and 100. By convention, we identify these as our double crossover class. Whatever occurs least frequently in your data set is your double crossover class. Highlighted in blue here, they make it really easy for us. They already put the parentals together, and the parentals are just offspring that look like their parents, one or the other parent. So now that we've identified what goes with what, we can reorganize our data set and make it a little bit more visually easily navigatable. From there, because we have our double crossovers grouped together, we've identified them, we can use them to identify our gene order. So by seeing which gene switches places in a double crossover, we can identify what goes in the middle. So here we see A is switching spots. And in order for that to happen via double crossover, it must be in the middle. So our gene order is BAC. So far, we've figured out how to organize our data, who our double crossovers are, who our single crossovers are, and what our gene order is. How can we use that information? Well, I've rewritten our data with the correct gene order. And from there, we can determine between which genes these crossovers are actually happening. And from there, calculate our recombination frequencies. So in pink, and this is where I made a mistake, so I'll get to that. In pink, we have our crossovers between A and C. And we're going to use these numbers in concert with our double crossovers because they have something in common. The double crossovers have a crossover between A and C, and so do these pink single crossovers up here. So we can use that to find the distance between A and C, not A and B. I made a mistake there. A lot of mislabeling is going to go on from this point forward, so bear with me. I'm going to talk us through it. So 1010 plus 970 plus 100 plus 140 divided by the total number of offspring, 5,742, is going to give us 38.66 map units. Now, we want to keep track of this number, that 0.3866 here, because that's going to be important for future calculations. Our distance between A and B is 18.46, using 400 and 420 and the double crossovers to calculate it. Now, you'll notice in my map, I've gotten this completely jacked up as well. B should actually be C. That pink segment is the distance between A and C, and the distance between A and B should be blue. So now we've created our map. For chucks and gigs, we're going to calculate our degree of interference, which can only be done if we figure out what our coefficient of coincidence is. So we're going to take our observed number of double crossovers and divide it by expected number of double crossovers. And observed is easy because you just take it from your data table. But where are you getting this number? Where are you getting that expected number from? And that's going to come from multiplying your recombination frequencies before you multiply them by 100. You're going to multiply them together in decimal form. So 0.3866 times 0.1846 is equal to 0.0173366. You're going to multiply that by the total number of offspring, which will get you 409.785. So we divide the observed and the expected, and we get 0.5856. Interference can be calculated by taking 1 and subtracting the coefficient of coincidence, which will give us 0.4144. And interference is positive here, which means crossovers happening in one region of a chromosome are actually having a negative impact on the ability of other regions of the chromosome to cross over. So that's why we're seeing fewer crossovers than we expect to see. Thank you for watching.